So let us copy this one. I have to give the mechanism for this reaction. You have to propose the mechanism. So try this one. You can try. So you see what are the things that is happening here. You have a oxygen this side. There is a ether oxygen, and this oxygen is here. So no change. I have a loss of double bond. So there is a double bond, and this side there is no double bond. So one thing I know. So one change I can absorb. There is a basically loss of a double bond. So this is a loss of a double bond. Now you see, another thing that is important in the medium is acidic. So this is a acid catalyzed. So this is a acid catalyzed mechanism. Now one another important point, this oxygen is basically connected to this carbon. So if you see 1, 2, 3, 4 and this 5, so you will have 1, 2, 3, 4, 5 and oxygen 6. So if you connect this oxygen to this carbon, you will have a 6-membered ring, and perhaps this is the ring. And there is also verified because there is a CH3 group that is attached to the carbon that contains oxygen. So this is CH3 group. So it looks like this oxygen is basically attacked on this carbon. Now things are easy. You can try yourself. Take some time. So let me write. So you have this, and you have this OH here, and this side you have CH3. Medium is acidic, so you have H plus. So what you will do? So let us attack this alkene on this H plus. So you will have a 6-membered ring. So let me write. So this is a 6-membered ring, and this double bond is basically gone. And here you have oxygen. So this is oxygen. And now there will be a plus charge on this carbon, and this plus charge is basically resonance stabilized. So you see, you can write one resonating structure for this molecule by putting this lone pair here. So you can say this is a resonance stabilized. This carbocation is a resonance stabilized. So 3-degree carbocation. So this carbocation is a 3-degree carbocation, and as well as a resonance stabilized. Now what will happen in the next step? This oxygen, basically lone pair, it attacks here on this carbon. So if I write that, I can write a 6-membered ring containing oxygen. So there is oxygen and then is a CH3. And now this carbon and this oxygen gets connected. So you will have a 6-membered ring again. So you will have oxygen here because this carbon contains oxygen, and now 1, 2, 3, 4. And this containing 5. So you have a 6-membered ring. So let us make a 6-membered ring. And this is the 6-membered ring you have. Are you getting or not? And this carbon, the carbon containing oxygen, will have a 1 CH3 group. Simple. Now this oxygen will have H plus. So what you can do is, in the next step, you can lose H plus. The medium is acidic catalyzed. So if you lose H plus, what you will have? You will have a 6-membered ring this side containing oxygen. And there is a CH3. And this side also you will have a 6-membered ring. So this is a 6-membered ring containing oxygen. Are you getting or not? So simple. And here you have a CH3 group. So this is the thing we have to prove. So let us say this is the mechanism. Same molecule can also write, if you wish you can write. So this is equivalent to the molecule that is given to you in the problem. I can write in a better way. So you have this. I need a 6-membered ring, and I can write something like this. So this is the final product. There is a CH3 group attached also. Are you getting or not? So simple.